Hello and welcome back. As you know, computers are very good at processing files, so the topic of the videos this week is going to be file processing. There's not very much new to learn here, there's just a few new commands and concepts, but we are going to spend some time putting those concepts together with the concepts we've already learned to do a few worked examples of processing files. So computers process many different types of files, and this may be numerical or scientific data, which is our focus for our examples in these videos. It could be commercial data processing, such as a list of transactions in a bank account, document processing, such as the type of processing Microsoft Word would have to do on its documents, interpreting or compiling programs, such as programs written in C or Fortran or even Python. Image processing applications like green screening for movies or TV programs, and crawling the web to find a list of email addresses. Okay, so many different applications, but most of the concepts, or many of the concepts of file processing are common across these different types of processing tasks. So in processing numerical data, often our algorithm or our series of steps will look something like this. Initially, we'll open the file, and that gives us access to the content of the file. We'll then extract the data from the file, which may be really simple, such as just splitting up the components of a comma-separated values file, or it could be really complex, like parsing an XML or HTML file. We'll then do step 3, which is process the data, and output and display the results. Now sometimes if the file's really big, it may be too big to effectively process all of it at once, so we may break up and interleave some of these steps by reading a chunk of the file to give us a large set of memory that's not going to overtax our computer's memory, process that component, and then output results associated with that component before reading another subsection of the file, doing the processing on that subsection, and so on. So files are just sequences, and we have a new command called open that allows us to open one of these sequences. We need to specify a path, which is the series of directories or folders that we need to go to find the file, and we also can optionally specify a mode that the file will be opened in, which can be read, which is the default value, or write, or append, as we'll see in a minute. So the path is the file path, the series of folders that we need to go through in order to find the file. So it could be something like H:, which says on the H drive, there's a folder called 121, and inside that folder there's a file called junk.txt or junk.txt. Now Microsoft Windows would normally use backslashes to separate files, to separate folders, but Python's happy to do an automatic conversion from forward slashes. If you really want to use the backslash character well, you need to do // to escape the normal meaning of backslash as a special character in Python. If you don't specify the series of backslashes, you can just specify the name of the file, as we can see in this example over here on the line, on line 1 on the left. There's no file path being directed here, just the name of the file itself. So if the path, the series of slashes, is absent, then Python's simply going to look in the current directory, which is the same directory as the file the program is saved in. So untitled 1.py here is saved in a particular directory, and in that same directory there is junk.txt, the file that we're going to open. Okay, if we don't specify mode, we get R by default, meaning we're opening the file for reading. Otherwise, if we specify the string W, that means we're open for writing, and the string A means we're opening to append to the file, which just means add more data to a pre-existing file. Okay, the file object that we open is just a sequence of lines. So if I have a quick look at junk.txt and I happen to have it sitting here open in Wing, we can see it's just a brief poem from Roald Dahl, the most important thing we've learned, then \n, so far as children are concerned, \n, and so on. Right, so this file is in the directory, and you can see Wing is showing it to us there. It's in the directory users/AJC168, and untitled 1 is in users AJC168. It's in the same folder. Okay, so if I open this up, we can see what we're going to do is make data refer to a new object that's the result of opening the file junk.txt. And then we'll go through the sequence that we get as a result for line in data. And what we're going to do is print all of the characters in that line, or print the string that is the result of slicing that string from character 0 to the end but one character. So print the line without its final character. So the final character in this case is the \n, right? There's a \n or a new line character sitting at the end of this, at the end of each of these lines, and we don't want to print that out, or we'll end up with extra lines between our lines. Finally, we'll close off the file. So it's just good manners to close the file when we don't need it anymore. So if we run that, our program is simply going to read the file, open the file for reading, read the lines one by one, and eventually close the file. Right, nice and simple. Very little new to learn there. Alternatively, we could open the file, we could rewrite that program and have exactly the same effect by using a slightly different command to read the lines. Previously, we used the for loop to say for line in data. So it's a sequence of lines of data, right? And we use the for construct to grab each of those elements of the sequence in turn. In this case, what we're doing is we're reading the entire file into memory in one go. So we still open the file in exactly the same way as we did before. We now make lines refer to the list that is the result of reading all of the lines. So data.readLines. Readlines is a method for the object returned by opening the file, and it gives us a sequence of lines, and readlines returns all of those in one as a list. Then we can say for line in lines, in that list of lines, we print the same data out, everything up to but not including the \n at the end. So what are the pros and cons of doing it either this way or the previous way? Well, arguably this way is a little bit more explicit about what it's doing. It's reading all of the lines. That's pretty debatable. One of the nice things though with this is we can easily access the lines in an arbitrary order. So if we wanted to change, maybe do this in reverse order, it would be quite simple to do it, or back up through the lines in the file. That would be easier to do than it would be with our previous solution. The disadvantage of this technique, though, is if the file is huge, if it's an enormous set of data, we may not have enough memory to read it all into memory in one go. So here, this reads everything contained in the file in a single hit, and it makes the variable lines refer to all of that data in one go. Okay, so what is open actually returning? Well, it's returning an object that behaves a lot like a book and a bookmark. So the bookmark is initially at the start of the book when we're opening the book for reading. We're going to start at the beginning of the book, and we're just going to read characters or words or lines until we get to a particular point. When we stop reading, the bookmark is there, and the next time we start reading again, the bookmark will just move on from that point. Okay, so the bookmark is just left after the last character, word, or line that you read. Similarly, if you open the file for writing, which we haven't seen yet, but we will shortly, what's going to happen is the book is initially going to be completely empty, like an empty exercise book, and then you always start, as you write data to that file, the bookmark moves on, and you always start writing again at the location where that bookmark was left off. Okay, so the bookmark is automatically updated after each write, in the case of a file that we're writing to, or after each read, in the case of a file that we're reading from. Very briefly, we can also use similar techniques for opening resources that are not on the local file system, but are on the internet instead. So we could open up an internet resource, such as this page here. Here's the computer science web page. So that's just a set of data that's stored in a file, where that file is on a web server. Well, we can use some packages that have been written by others on our behalf that allow us to easily retrieve that data. So you don't need to know the details of this, but I can import that particular package, the URL library. I can then make URL a variable, refer to the URL that I'm seeking, and I can open up using a request of that URL library to open up that particular URL. I can now then get all of the lines by reading the web page and decoding it in a particular way according to the character coding. And then I can go through and print each of the lines contained within that URL. So if I run this program, we can see I've got all of the content for the web page that we were looking at a moment ago, and it's just printed it out to the shell here. So lots of data describing the content of that web page. Okay, and here's some computer science and software engineering about designing computer systems to help people do their work effectively and efficiently. And if we go off and have a look at this, we see there's that same text. Computer science and software engineering about designing computer systems to help people do their work efficiently and effectively. Okay, so that's a quick introduction to files as sequences that we can easily process. Next time, we'll look at putting some of these concepts together to do some scientific data processing. Thanks.